here we go. We are in day 2, so these are notes. Module 1, topic 1, lesson 3, day 2. So technically day 3 of the week, but day 2 of the notes. Okay. All right, so we are going to talk about slopes, and we're going to be writing equations of perpendicular and parallel lines. So that's what the focus is today. We need to recall that perpendicular lines form a right angle. So a right angle is just another way of saying a 90-degree angle, okay, at the point of intersection. So we're going to look at these 3 graphs, and actually we are only going to look at 2 of them. You can ignore this one here. Okay. We're going to consider them, and we are told, it tells us that each shows a line and its rotation 90 degrees around a point. So we're basically told this is a 90-degree angle here, which means that B is perpendicular to B prime. So we need to look at the slopes of B and B prime. So remember that slope is rise over run. So we just need to find 2 points on the graphs and count. So I'm going to pick, let's just say this point right here and this point right here. All right, it looks like it goes up 1 and over 1, 2, 3. So the slope of B, the little m down there, it denotes slope. So the slope of B is up 1 over 3. So rise of 1. Run of 3. Same thing with B prime. So I'm just going to pick 2 points here, that one and that one. You could pick any 2. So it looks like I'm going down 3 and run over 1. So for B prime, the slope is down 3 over 1. All right, looks like they've got some relationship there. Let's look at the next group. We'll come back to that. All right, so now we're told again, this is a graph that's a 90-degree rotation. So we're told that this is a 90-degree angle so that we know C is perpendicular to C prime. We're told that in the directions. We just need to figure out the slopes. So I'm going to pick 2 points here on C. Looks like I go down 2 and over 3. So down 2 over 3. So slope of C is down 2 over 3. And for C prime, pick 2 points here and here. So I'm going to go 1, 2, 3 up, and 1, 2, 2 over. So it looks for C prime, my slope is up 3, my rise of 3, and a run of 2. All right, again, similar numbers. Okay, let's see, I can almost get it on there. There we go. All right, so let's see if we can take a look here and figure out. It looks like we've got the same numbers. One's positive, one's negative. So like for C and C prime, C is negative, C prime is positive. For B and B prime, B is positive, slope of B prime is negative. So it looks like they have things in common. Are opposite slopes. So one positive and one negative. And it looks like they have the same numbers, 1 and 3, 3 and 1 for B and B prime, 2 and 3, 3 and 2, but it looks like they're flipped. So it looks like that they're flipped, otherwise known as reciprocals of each other. So we would say that perpendicular slopes, because we know they're 90 degrees, we know they're perpendicular, so we know that perpendicular slopes are opposite reciprocals, which means one is positive and the other is negative, and they are flipped of each other. Now remember, parallel lines have the same slope. Okay? So perpendicular lines have opposite reciprocals. Parallel lines have the same slope. Okay, and we're going to be dealing with writing the equations of perpendicular and parallel. You've probably talked about this before, so I'm not going to spend a lot of time going into all the transformations and that sort of stuff. But basically, okay, the perpendicular have opposite reciprocals, parallel have the same slope. So we're actually going to jump ahead to page 43. And we're going to get into horizontal and vertical lines and writing equations of horizontal and vertical lines. All right, so it asks us to use a straight edge to extend GK to create line P, and then to extend each one of these. We're just going to extend one of them. So we're going to go ahead and extend GK. Now let's keep it in this. Hopefully it'll, come on, there we go. So we're going to extend GK, and luckily it is on a grid. Okay, and this is line P. Okay, and then we're going to extend, let's just extend GH. We're not going to do all of them. They all have, once you do one, you kind of have done the other. And then we got to find some, oh, and GH is what? Q. So this is line Q over here. All right, and then we need to find some points. So I need to find some points on line P, and I need to find some points because we're going to be dealing with slopes. So I'm going to go ahead and label this point right here and find the coordinates of it. That's 0, 4. Okay, I'm just going to pick this point right here, which happens to be the point 7, 4. And I'm going to pick this point out here, which happens to be the point 16, 4. Okay. And then I'm going to pick some lines along P, or some points along P. So I'm going to go ahead and pick this point right here, which happens to be 4, 0. I'm going to pick this point right here, which happens to be the point, oops, 4, 9. And then this point up here, which happens to be the point 4, 15. All right, so I'm just going to kind of take a look here. Okay, they talk about this in kind of points parts 2, okay, on question number 2 and that sort of stuff. But they kind of do it a little bit differently than I'm going to. I'm just going to kind of look at the points on Q, because we're talking about the horizontal line. So again, here we're talking about the horizontal line. So something I notice when I'm looking at all 3 of the points on point Q, that they all have 4 as their y coordinate. Well, that's because with a horizontal line, it doesn't go up or down at all. It just goes left or right. It's kind of like a translation of this point all the way along here. It translates along the x-axis. The x numbers change, but the y numbers don't. So if I was going to describe the slope of it, we've kind of already talked about this. There is no, so if we're talking about slope, rise over run, I could pick 2 points, but there is no rise, so there's 0 rise. And I could pick anything. There's multiple runs. If I go from the point 0, 4 to 7, 4, there's a run of 7. But if I have 0 things and I divide it into 7 groups, I still have 0 things. So the slope of a horizontal line is 0. Okay. Now, if I look at the vertical line as well, and we'll come back here. You guys can look at the whole page, but I have to kind of move it up and down. If I look at the vertical line, I have P here. I have the same number in the x-coordinate, so 4, 0, 4, 9, 4, 15. That's because it doesn't move along the x-axis at all. All it does is move up and down. It's like a translation of a point up and down this line. It always stays with an x-coordinate of 4, but it changes the y-coordinate. So again, if we're going to look at the slope, rise over run. Okay, it rises a lot. In fact, I think it goes from 0 to 9, so it rises 9 if I was to pick 2 of my points, but it doesn't run at all. It has 0 run. Now, I can't divide by 0, so this doesn't have no slope. It has an undefined slope. In our number system, it is undefined. Okay, we can't take any amount of items and divide it 0 times. Doesn't make sense. So a vertical line the slope is undefined. So be careful. Don't ever say that it doesn't have a slope. A horizontal line has a slope of 0. A vertical line has a slope that's undefined. Okay. All right. So we need to talk a little bit about equations of vertical and horizontal lines. So we're going to go on to page, I think we're on 44. Yep, page 44. So determine whether each of the given statements is always true, sometimes true, or never true. Now, this is one of these favorite things that they do in the state. They love asking these type of questions. The always, sometimes, or never. So anytime that you're asked to do this, you always have to kind of think, is there a possibility of an option outside of what they're asking? So for part A, it says, are all vertical lines parallel? And a reminder, parallel lines have the same slope. So you're thinking, okay, vertical lines all have a slope. M stands for slope. Vertical lines all have an undefined slope. So yeah, they're all the same. All vertical lines are undefined, so that means that they all have the same slope, so they're parallel. But there are some times where you may be given 2 equations of a line and they're exactly the same line. Same lines are not parallel, they're same. So the answer to this is sometimes true. And why is it not always true? Because it could be the same line. And the same falls for part B. Are all horizontal lines parallel? Well, again, you're saying, okay, horizontal lines have a slope of 0. All horizontal lines have zeros, therefore they all have the same slope, therefore they're parallel. But again, 2 equations could be exactly the same. So this is sometimes true. It's like 99% true, but it's not 100% because they could be the same line. All right, now the relationship between a vertical line and a horizontal line. Well, we know that a vertical line and a horizontal line meet at, so vertical and horizontal meet at 90 degrees, which makes them perpendicular. You might be saying, well, wait a minute, perpendicular lines, the rule for perpendicular lines are that their slopes are opposite, meaning one has to be positive and one has to be negative, reciprocals, where the top number, the numerator, becomes the denominator and the denominator becomes the numerator. And you might be like, well, wait a minute, how does 0 and undefined? One's not positive, one's not negative. But horizontal and vertical lines are special cases where they fall under the 90-degree thing. And so because they meet at a 90 degree, they are perpendicular in that part of the definition. Because we know that all perpendicular lines meet at a 90 degrees. So, all right, so this is part of kind of like your homework. Okay, so you may want to pay attention if you've started zoning out a little bit. So you need to write an equation for a horizontal line and an equation for a vertical line that pass through the point 2, -1. Now, again, I'm a real visual learner. I got to kind of see what's going on here. So I'm going to just kind of do a quick sketch over here. So this is my coordinate grid here, my x, y. Point 2, -1 is like right here. So this is the point 2, -1. And I need to write the equation of the horizontal line that passes through that. So I'm just going to kind of do a little dashed line here. Now, I know that the horizontal line has a slope of 0. Okay. I could find points along that and try and help me with that. But it's got kind of a little bit of a special case going on here. Okay. Again, if I take a look at some different points, the point right here is 0, -1. The point right here, say, is like -4, -1. It's the y coordinates that are always the same on a horizontal line. So I also notice that the horizontal line crosses the y-axis. So that tells me that it's going to be a y equals whatever the y coordinate is that it needs to pass through. In this case, my y coordinate is -1. It doesn't matter where I go along this line here, my y coordinate is always going to be -1. So the equation for the horizontal line is y equals -1. All right, now for the vertical line. Okay. The vertical line that's going to go through, and of course it's not going to change colors for me, is going to go through, whoops, if I could draw a dash line that's decent there, like that. I could pick points along here. This is going to be 2, 3. This down here, say it's like 2, -5. It's the x coordinate that's the same always. So just like with the vertical or the horizontal line, the vertical line has the same thing. It passes through the x-axis. Doesn't ever pass through the y-axis unless it is the y-axis. So a vertical line will always pass through the x-axis. That means it will always equal whatever the x-coordinate is. In this case, the x-coordinate is 2, so the equation of the line is going to be x equals 2. And that's for vertical lines. So if you're asked to write an equation for a horizontal line or an equation for a vertical line, remember a horizontal line goes through the through the y-axis, so it's going to be y equals whatever the y coordinate is. Vertical line goes through the x-axis, it's going to be x equals whatever the x coordinate is. Okay. All right, another one kind of like your homework. Write an equation of a line that's perpendicular to the line given by x equals 5 and passes through the point 1, 0. So this always kind of throws students off because they start thinking that they have to kind of get some different information going on here and that sort of stuff. So again, visual learner, I have to sketch it out. So I'm just going to take a look here. So I have to do passes through the point 1, 0. So 1, 0 is about right here. And it is perpendicular to the line x equals 5, which means that it's going to cross the x-axis, okay, at 5. So let's say about right here is the x-axis at 5. Let's try that again. X-axis at 5. There we go. So this is x equals 5, crosses the x-axis, vertical line. And I need to draw the line or figure out the equation of the line that passes through this point here and is perpendicular. So basically it's going to be a horizontal line. Okay? And this again is the point 1, 0. So horizontal line, okay, because this is a vertical line. This tells me right here this is vertical. And if it's going to be perpendicular to a vertical, then it has to be horizontal. Horizontal. Can I not spell today? All right. Horizontal lines are the equation y equals. So all I got to do is look at what the y coordinate is. So that means it's going to be y equals 0. Okay. All right. Next one. Let's see if we can do this without drawing a picture. So write an equation for a line that is perpendicular to the line given by y equals -2 and passes through the point 5, 6. So first off, I got to figure out what's my original line. What does it look like? Well, y equals -2 is a horizontal line. So that means perpendicular to horizontal is vertical. That means it's going to be an x equals. So I need to look at the x coordinate of the point. So it's going to be x equals 5. Okay. All right, so that's similar to some of your homework. Okay. Now we're going to move on to page 45, and we're going to kind of do a couple more examples of what your homework looks like. Okay. Now we're going to do perpendicular lines that are not horizontal and vertical. Okay, so horizontal and vertical, I'll just go back real quick. Okay, again, horizontal and vertical are always perpendicular. You have to figure out what the original line is. Then the perpendicular one's going to be the opposite. So if it starts off vertical, you're going to be writing horizontal, so it's going to be a y equals. If it starts off horizontal, you're going to be writing vertical, so it's going to be an x equals. Now, this one, all right, we have to sit here and think through the fact that with perpendicular slopes, are opposite reciprocals. And if you need to write that at the top of your homework, then do it. Okay, the more times you write it, the more times you're going to remember it. All right, so we need to write the equation. This is exactly of what your homework is going to be. This is half of what your homework is tonight. You need to write the equation of a line perpendicular to y equals 2x plus 1 that passes through the point 6, 2. Now, you're used to probably doing the y equals mx plus b. We are going to use a formula that looks like this. Write it down. This is called the point slope. The nice thing about the point slope is that all you need is a slope and a point, and then you just plug in numbers. Okay? The first y and the first x always stay a y and an x. They don't ever change. Those are the only letters that will stay in there. The second y and the second x come from the point. So this y, comes from the point, and this x comes from the point. And then the slope is the m. Okay? So you basically already have, if we're trying to do number 1 here, you already have 2 of the 3 numbers you need to plug in right there from the point. You just have to remember which one is the x and which one is the y. So I'm going to write out the formula without the second x, the second y, and the m. So it's going to be y minus, we're going to put a number in there, is equal to a number in there, x minus, and then we're going to put a number in there. All right, so the y coordinate is 2, so the 2 is going to go in there. The x-coordinate is 6, the 6 is going to go in there. So you already got those. What we need to figure out the slope. Well, we're doing perpendicular. So it's perpendicular to this line right here. So we first have to figure out, which is in the form y equals mx plus b. So the number in front of the x is the slope. So that means 2 is my slope here. That's my original slope. So opposite reciprocals for perpendicular. So if my original slope is positive, that means my perpendicular slope is negative. If my original slope is 2, or in this case I can write it as 2 over 1, my perpendicular slope is going to be 1 over 2. So opposite, 1 positive, 1 negative, reciprocals, the numerator and the denominator flip. So I have negative 1/2. So the equation of my line is y minus 2 is equal to negative 1/2 x minus 6. And that's it. You don't have to do anything more. You don't have to put it into slope-intercept form. You can leave it in point-slope form. If they asked for it in slope-intercept form, then you would have to just distribute the negative 1/2 and then add the 2. So you could rewrite it, but point slope is a perfectly okay. All right, so let's do another one here. Okay. Write the equation of a line that's perpendicular to y equals negative 3/4 x that passes through the point 3, negative 8. So again, we already have 2 of the 3 points there. So I'm going to go ahead and write y minus negative 8, we'll clean that up in a minute, is equal to, I don't have my slope yet, x minus 3. So all I did was plug in my y into the y part, my x coordinate into the x part. Now I got to deal with my slope. It's the number in front of the x. So my original slope is negative 3/4. My perpendicular slope, if my original is negative, that means my perpendicular is positive. 3/4, I flip it, becomes 4/3. So positive 4/3. And now all I have to do is just clean it up a bit, because we don't write minus and negative 8. So it's going to be y plus 8 is equal to 4/3 times x minus 3. Okay. All right. I want you guys to try number 3. Well, actually, we'll do it together. All right, because it's a little bit different. All right, so we're going to write the equation of the line that passes through the point. So again, we already have our point here, but they don't give us our slope. We have to find it out. Okay, so remember slope, y minus y over x minus x. Now you could plot the points. So you could do a little sketch over here. Negative 5, 3 is here. Negative 1, negative 9 here, and count. And that would be perfectly fine. There's nothing wrong with that. You can just count down and count over and do a quick sketch. But the formula is also another way. So we just have to subtract our y's. So we have 3 minus a negative 9, which is like 3 plus 9. Negative 5 minus a negative 1, which is negative 5 plus 1. So we have 12 over negative 4, which is negative 3. Now that's our original slope. So that means the perpendicular slope, if the original is negative, the perpendicular is going to be positive. And this technically is negative 3 over 1, so it's going to be 1 over 3 to do the reciprocal. Now we have our point, 6, 2. So I'm just going to write it out here. Y minus 2 is equal to 1/3 x minus 6. Okay, biggest mistake that students make is they forget that the formula is a y minus y is equal to m times x minus x for the point slope. Okay, and they tend to drop the negatives or forget about the negatives. Okay. All right, so that's basically what your homework is. You're going to be writing equations of lines that are perpendicular to given lines. And you are also going to be writing lines of horizontal and vertical lines given a point and doing that. So make sure and look back on your notes.